Hello everyone, Krishna this side. So in this video, I'll be covering this LeetCode problem 1233. Remove subfolders from the file system. You can pause the screen and read the problem statement. I'll directly explain you on the screen what it is trying to say. These are the examples. And in input, we have given an array which contains strings. Okay. So yes, that is something what we will see why it is being given and what is the action that we have to perform with this particular array. Okay. So in the constraints, we have given this folders length. So its length is basically whatever this array that has been given, its length is basically 10 to the power of 4, and individual strings length is basically 100. It goes all the way till 100. Okay, so based on these constraints, we will try to write down the algorithm which will basically suits for this particular code. So let me just quickly connect the screen. Okay, now in the input, right, so we have given an array. Okay, this is the array. Let us suppose this is the array that has been given to us. From this array, okay, this array, all these strings are basically nothing but folders. Okay, these are all folders. That is something what they have they are saying. From these folders we have to remove the subfolders. Okay, that is the whole idea. So we have to just remove the subfolders from this given array. After removing whatever the remaining folders that are available with us, that is something what we have to print into the output, or we have to return from this particular function. So yes, what is the definition of this particular subfolder? Okay, this folder is defined as a subfolder if its parent folder, okay, the parent folder is actually available in the given array. Okay, that should be the bare minimum condition, because we cannot simply say that any folder is a subfolder if we don't find its parent folder, right? And the subfolder must start with its parent folder. Okay, subfolder, whichever the folder that we are saying that yes, this is a subfolder, then that subfolder must start with its parent folder. Okay, I think this statement easily gives us clarity like what we have to do from this particular one. Let us say that this is the folder, that is the first folder available. Okay, a slash b. Next is like a slash b slash c. Here if we notice this, whatever this a slash b that is given to us, this a slash b, it actually started with this particular one, a slash b, right? So entire this particular folder actually started with this particular one. So this is actually a subfolder of this one, right? We can easily say that. So yes, in a folder directory, wherever we store the data and directories, all that, there also we notice, right, like when we go inside a slash b, we notice we have multiple subfolders inside there. So here it is like extra c, that is a subfolder, like inside is a slash b. That is the first thing that we notice. Yes, this is something what we have to remove from this one. Next is like a slash b slash d. So again this ab, whatever the ab that is there, it basically started right over here, correct? This a slash b slash d. So yes, this is also subfolder which we have to remove from this one. So it basically starts with one. So ab is actually parent folder of this slash a slash b slash d, correct? So again, like it is a slash b slash d, de, something like. So this ab basically started right over here as well. So this is also subfolder, that is something what we have to remove. Okay, so when we notice a folder like structure here, if we focus right over here, so we have slash a slash b, that is the parent folder. Inside there we have slash c slash d slash de. So all these are the subfolders. So those subfolders we are actually targeting, and we have to remove all those subfolders. That is the whole idea. Now next is like, if we go ahead, we notice that here the next string is basically slash a slash d, correct? That is the string that has been given to us, slash a slash d. Okay, here slash a slash d is given. And when we compare this slash a slash b with this slash a slash d, both are not subfolders of each other, right? Slash a slash b is independent subfolder, slash a slash d is completely different folder. Yes, these are different folders. So yes, slash a slash d needs to be considered, because when we start comparing these characters, slash a basically both are same, but slash b is denoting completely different folder, slash d denotes completely different folder. And in this particular folder structure, we have no slash a given to us. Okay, if slash a is given, then definitely slash a is actually parent folder of these both the folders. So these both folders we can remove easily. But slash e is not actually available. So definition clearly says that a folder is defined as a subfolder if its parent folder is available. So slash a is actually not available to remove the slash a or slash t. Okay. And if it is available, and that subfolder must starts with the parent folder. So both the conditions should match. So slash a is actually not available, and both this slash a slash b or slash a slash t, they are not parent of each other, right? Slash a is common between both of them, but slash d and slash b are different. Okay. So both the conditions should match. So slash a is, since slash a is not available, we cannot remove the slash a or slash t. They are independent subfolders. Okay. So yes, that is the whole idea. Now slash a slash d is completely different folder. Okay. And next is like slash a slash d. Now here we, if we notice here, slash a slash d and slash a slash de, both basically starts with slash a, right? Here it starts with slash a slash a. But when we notice, right, so whenever we go inside a folder structure, inside slash a we will be having d or de. These two different folders we will be having, correct? So both a folder must be having unique names, right? And both the names are unique. So we cannot say that the slash a slash d is actually parent folder of the slash a slash de. Okay, that is the whole idea. So what we will do whenever we are comparing with any two folders, we will just have to make sure that we will put slash after that, so that it will be, gives us clarity. When we comparing character by character, slash is here and e is here, so both the folders are different folders. That is the idea that it gives us whenever we try to compare these folders. Okay. So yes, now the idea is pretty much clear. Like we just have to remove the parent folders, and we have to just check that whether the previous folder is actually available in the given directory or not. Let us say that if slash a is actually available, that means like slash a for slash a, like all these are basically started with slash a, correct? So every single character, every single folder needs to be removed. Okay, because with this slash a, every single folder basically started. So under slash a only all these folders are available. So yes, all these folders needs to be removed. But in the given input array, we don't have slash a, so yes, we cannot remove this one. Now, by simply observing this one, okay, by simply observing this particular code, I mean a particular array that is given to us, we can say that, well, let me just clean this up. If data is actually in a sorted order, if data is actually in a sorted order, we can easily solve this particular code, right? We can easily solve this particular one. How? See, when the data is basically sorted order in lexicographical order, once the data is actually sorted, this particular slash a slash b comes first. Then after this, any extra character that we are adding after this, like slash a slash b, then e is something what it has been added, correct? So these characters will be available right after, next to each other. Okay, so that way it gives us idea that okay, now based on this, whatever the previous character, previous string that is available with this, with us, we will simply compare with this current string. Okay, and we will check that whether this, whatever this previous string that is there, is it starting with this current string or not. Okay, let me just clarify this, what I'm trying to say right over here. So if the data is actually in a sorted order, so this particular data is not actually sorted order. If we notice right over here carefully, so this after BDE, there should be this D should be at the last. Okay, this particularly, I'm not sure if I missed something, but when we sort this data, how it looks like after BDE, there will be like A slash D, or then there is like A slash DE. Like this, the data is actually available, right? Then this data is actually sorted. So yes, first thing is like we sorted this data. Okay, next step is like the first string that is there, definitely its parent is not available in the given array, because since the data is actually sorted, the lexicographically smallest string is actually available at the stop, at the start. So whichever the start data that is there, its parent never, we never find its parent in the given array. Okay, so yes, that is something what we will simply put it into the answer string. Okay, this once we sorted this data, that is actually available at the start of the string. Now our pointer basically points right over here. Okay, let us suppose that we are having a pointer which basically starts right over here. We will simply compare this. Now we will start looping from this particular given array. The first is like this, slash a slash b slash c. Okay, this is the first data that is there. So we will simply compare it with this one, whether this all these characters that are there, whether they are started with this one. Okay, so here if we notice slash a slash b slash c, uh, here let us directly put the slash, and I already explained you like why we are putting this slash right after this particular one. So we will pull from this one, like slash a slash b slash, and we will check that whether this is actually available in this particular current string or not. Yes, it is actually available, so we will simply ignore this one, we will not consider it in our answers list. Now pointer will be still pointing right over here. This pointer will be still start pointing right over here. Next, while running from this loop, we will be right at this particular location. So slash a slash b slash d is the current string, and this is the string that is available at the top in our answers list. So we will simply compare it with that one only. So again, slash a slash b slash c, this is actually available right over here. Yes, it is available. So see, this is like the subfolder of this particular parent folder that has been given. That is the clarity that we can get it easily. So I mean, see, simply looking into this particular question, this idea comes in our mind is like we can easily sort this data and we can easily start comparing these strings character by character at any point in time. If we notice this entire string is available, this whatever the string that is available in the answers list, if this entire string is actually part of any particular string, we are done. We will say that this is a subfolder. Okay, this is a subfolder, this is a subfolder, so we will not consider this in our answers list. Next is like slash a slash b slash de. Again, when we compare this slash a slash b slash this is actually available in answers list, so yes, we will not consider this one. We are done. We will simply ignore this one. We will not put this into the answers list because we have to remove the subfolders. Next is like slash a slash d. Now when we compare this current string slash a slash d with slash a slash b, slash a are common, but b and d are different. So yes, this is completely different folder. That is something what we have to put it into the answers list. Okay, so we put this into the answers list. Now our pointer here, it will point right over here, because going ahead, this whatever the new data that is available, based on that is data is actually sorted, right? The lexicographical order is basically it is maintaining. So if I compare this ab with this a slash de, it is it doesn't make any sense at all. Correct, it doesn't make any sense to compare this a slash b comparing with this next any current character, the current string that we are at. Okay, whichever is the previous string, if we try to compare it with that, at least it will give us idea like yes, this is actually, since the data is lexicographically sorted order, so yes, this could be parent of this current folder. Okay, so yes, we will simply compare it with slash a slash d of this new string. By comparing this, again we notice right over here the current string is this one, slash a slash de, and our string available in this one is like slash a slash d. So if we simply compare, this gives that okay, slash a slash d is actually available, this is a parent folder, but it is not, right? It is not. So what we have to do, we will simply put here a slash. Okay, here we will simply put whatever the string that we are taking out from the answers list, we will simply put slash right over there, and then we will compare. So here it is a slash, here it is a e, so both the strings are different. So this is the string that we have to put it into the answers list, new string. That is something what we will put it into the answers list. Okay, this way we can generate the answers. We have different ways also to write down this particular code, but I think this is the easiest and simplest way that easily can fit in our thought process. Of course, we can write this code with the help of try as well, but as if you have not solved any question with the help of try, just make sure that you will attempt this particular question with the help of try, because it is really important to understand the new data structures as well. And try is basically mostly used when we are trying to write any code in a folder like of structures. Okay, so it is best to start particular try algorithm to solve this particular question. Okay, you will get hands-on practice, and going ahead you will get this clarity with the help of try also. We can solve this type of questions as well. Okay, so yes, make sure to attempt this particular question with the help of try as well. If you stuck anywhere, if you are not having familiarity with the try particular data structure, do let me know. I'll create a video about this try. Okay, and I'll solve this particular question with the help of try as well. But make sure to make sure that if you haven't solved any question with the help of try, or you are not having any idea about this try data structure, make sure to learn from this particular problem. Okay, so once we are done with this, let us start writing that particular code. So first thing is like we will sort this array. Data is not actually in a sorted order, it is not mentioned in this particular given question. Okay, so yes, we will sort this data, that we will get the clarity. And first thing is like we'll create this list. That is something what we have to return ultimately. So the list is like answers list, new array list. In this list, first data is something what we will add. Okay, answer list dot add this folder of 0. That is something what we will put it into the answers list. Now we will run a for loop starting from first. This goes all the way to folders dot length and I plus plus. Okay, next is like from this answers list, we will take whichever is the latest data that is available in the answers list. That way only we will compare. It doesn't make sense to compare from this answers list every single string that is available, string by string. We don't require to compare all the strings that are available in this particular answers list, right? Whichever is the top string that is available, we should only compare it to that. If both the strings are different, definitely we will put this new string into that one. Okay, that is the whole idea. So let me create here a pointer ptr equals to 0. Now what we will do, we will just pull out the current string that is available from the folder. So string current string str equals to folder of I. Okay, from this we pulled out the previous string is like that is available from the answers list is like previous string equals to answer list dot get ptr. From the based on the pointer we will get it. Okay, so we will pull that string, and here we will add slash. Okay, it should be forward slash. That way we will get a clarity like the entire previous string is actually part of this current string or not. Okay, simply we can compare character by character. We can run a for loop the moment this previous string entirely available in this current string. If that is the case, we will simply avoid putting this current string into the answers list. Okay, that is the whole idea. Or else we can utilize the default functions that are available with the string. It is like starts with. So this current str, if it starts with this previous str, that means like the entire previous string, if it is available in this str, if it basically starts with this entire previous string, that means we are not considering this previous str, whatever the current str, because this current str is actually a subfolder of this previous str. That is something what it basically says. So in that case we will simply continue, or else if it is not starting with this one, we will simply put this into the answers list. So answers list dot add this previous this current str. Okay, and now pointer should increment it, so that whatever the new current string that is there at that particular location, there we are pointing it and we are comparing it with any new strings with this particular one. Okay, so once this is done, we will return the answer list. I guess that's how we can write down this particular code. Let me try to run and see if it is showing any issues or not. Okay, there are wrong answers. Okay, let us see why it is getting wrong. So after slash a, slash b and d is also it is showing. Okay, yeah, here it shouldn't be having any space, right? Okay, I think that was the issue. Okay, it is getting accepted. Let me submit this code and see if it is working fine or not. Now talking about the complexities, here let us say that this folder's length is basically n. So sorting will take n log log n. Okay, that is the first thing. And this answer list basically holding all the strings that are available. At worst case it will basically hold, so it is like n strings that it is holding. So each strings length is like n cross l. That is the whole point when it is storing that answers list. Okay, but that is fine, like whatever the length of the string, those strings it is basically holding into this answers list. Okay, ultimately that is something what we have to return it, right? So space, we are not worrying about like what is the space and all. But now further ahead, going ahead, this particular for loop basically runs all the way to n. Okay, and this comparing of the character by character starts with function basically runs from start of 0th character to whatever the length, smallest length that we have, this previous string length. It goes all the way to that particular point. So it is like if its length is l, so it is n cross l, because every single character it is going for all this comparison. Okay, so this way this entire for loop basically runs in n cross l. So overall complexity is time complexity n log n plus n cross l, whichever is the minimum, that is going to be the complexity. Okay, I hope you get this idea like how we are doing it, this particular one. And do let me know if you want a try solution as well. If you are new to this try and never solved any particular question, I'll create a playlist for the try as well as I'll solve this particular one. Okay, so yes, with that said, if you get the idea, thank you for watching this video. Bye bye.